Everyone. I am Danielle Phenol, Marketing and Training Coordinator at SIS. We are really excited to host this plant simulation session with our expert, Patrick Delaney. Before we get started, just a few quick notes. Please submit any questions to the Q&A section. We will have a live Q&A at the end to address as many questions as we can. Be sure to participate in our live polls throughout the webinar. This session is being recorded, and a link to the recording will be sent to you within 24 hours. And finally, we would really appreciate it if you would take a brief survey after you exit the session today. With that, I'm going to kick it over to Chris Hinks for our first live poll.
Love it, Danielle. Appreciate it for the warm introduction. Good afternoon, good morning, everyone. Again, my name is Chris Hinks, Client Engagement Director at SIS. And I thought the best way to kick this session off with Mr. Delaney is get some feedback from you. So we're going to launch our first poll question. And we would love your participation before we begin with today's content from Patrick. So the question is, what is your biggest challenge today in optimizing your production processes? Is it too much time spent on manual production planning? Are you having difficulty predicting the bottlenecks before they actually occur? Are you seeing too many high costs from trial and error improvements? Or are you having limited visibility across different production scenarios that you've been working on? So we'll give you a few more seconds to enter in your answer, and then we'll see what the results are and pass it over to Patrick. All right. Well, looks like we're consistent, Patrick, across the board right now. 33, 33, 33. Okay. Give folks a few more seconds to enter in their answers. Again, the question here on your screen is, what's your biggest challenge today in optimizing your production processes? Again, your participation is greatly appreciated. Just waiting for a few more folks to enter in their answers, and then we will show the results. All right, we've got more than 50%, which is engaged, which is always a positive, Patrick. I'd love to see that. So let me go ahead and share the results. And there we go, Patrick. So as you can see, it's split as far as the two highest, the prediction piece as well as the trial and error with costs associated with that are the top two answers on what their biggest challenges are today with their production processes.
And that makes sense. Obviously, predicting bottlenecks is a tough thing to do, but luckily, it kind of ties right into what we're talking about here, which is plant simulation.
Love it.
Optimizing bottlenecks is kind of the whole point.
All right, Patrick, having said that, the floor is yours.
Perfect. Thank you, Chris. Hey, everyone. My name is Patrick Delaney. I come to you with about 7-8 years of plant simulation work and projects under my belt. A lot of projects I'll talk about during this presentation, just in general. And yeah, let's just jump right into it and look at the agenda for this presentation. So first thing we're going to cover is the question, what is plant simulation? So we're going to define it a little bit, make sure that you all understand what it's all about and how it can be used. And then we're going to jump into the digital twin concept, how it's important to you. I'm sure none of you have, I'm sure all of you have heard of it, but none of you have not heard of it. So because it's just such a common concept, especially with Siemens products. Why plant sim and why now? We'll jump into that right after that. I'll kind of cover some projects I've been on and kind of explaining what the advantages of plant simulation are. And then the benefits, what can you achieve with plant simulation? Number 5, we're going to jump into some typical project planning. And then number 6, we're actually going to skip and just do some demonstration of Factory 51. And I can jump into what it's all about, the basics of plant simulation, and kind of explain what's going on there. Then we'll do a summary of the presentation and everything that I covered, and jump into some questions and answers at the end. So let's get moving. So what is plant simulation? So I have this nice little definition here of discrete event simulation tool and what it actually is. But let's look at a few facets of this definition, just to break it down and get a little more clarity to what plant simulation has to bring to the table in terms of this discrete event simulation definition. So first off, let's start with transportation. The functions of a multifaceted system. One facet would obviously be, trucks, forklifts, AGVs, operators. I've seen bicycles used in many manufacturing plants. That is kind of a typical thing to look at in a discrete event simulation tool. And plant simulation is no different. I know this picture doesn't have any AGVs or anything moving around, but it does have robots, it does have conveyor belts, and it will have people in it once I play the Factory 51 example. Let's look at the next portion of this definition, individual components that occur in a specific order. Those are usually process steps. So deliveries that are coming in by trucks or vans, unloading with forklifts on pallets, and then unpacking with operators. Those are kind of similar, but key process steps in a transportation system, and it's everything that plant simulation can create. And then the last one is can be replicated. So this brings us kind of to the digital twin concept, utilizing real world KPIs in your processes today to compare our simulated process and kind of make sure that our simulation is matching real world as close as possible, so that when you make a change in the virtual environment, it reflects in the real world, and thus you're saving money by not having to, do it manually. And so that brings us directly to the digital twin and how we can replicate your processes in the virtual world. So what is a digital twin? I think you're all pretty familiar with it, but it's a virtual representation of a physical object. So if we're talking about a manufacturing process, maybe creating an airplane, creating a tractor, creating an engine, all of those have different components in it, different people, different machines, and all of those things are physical objects that can be represented virtually in plant simulation. So some questions you can ask while you're thinking about your process and thinking how plant sim could apply to your process, your manufacturing. Why are we running out of boxes consistently in shipping? So that could be an issue that is happening on a daily basis. Maybe you're working through it right now, but you can also do that virtually in plant simulation. Why are machines going down on a weekly basis? Maybe you look at replacing an old machine with a newer machine, or maybe you look at using some sort of component like an oil to put into the machine on a more consistent basis. Things like that. What can we do to fulfill a large order? That's another issue that is pretty common today, and it's basically something that we can cover in plant simulation pretty clearly, because we can look at the future of this simulation and how you can fulfill an order that is maybe 1, 2, 3 years in the future. Why plant simulation? So this is another portion of the tool that is pretty useful, which is material flow, optimization of material handling, production KPIs, shift scheduling, anything like that. That is all covered in plant simulation, as it's a flexible tool. I will cover later the programming aspect of plant simulation, which is not usually needed in many simple models, but that is also a key aspect of customizing your simulation to maybe fit an unusual use case in your process. Now that could be downtime or something very specific to the weather near your manufacturing plant. It could be anything really. But yeah, that is why plant simulation is a useful tool. It basically covers all use cases, and the use cases that it doesn't cover can be covered by the programming language behind it. Now, what are some benefits of plant simulation? Plant simulation has a lot of different benefits. I listed a few here. Detecting problems that would otherwise require costly and time-consuming correction measures. That's a pretty common use case for us. But some outside of the box use cases that I'll explain now is basically my project work that I've worked on. And so maybe changing a manual process with many decision makers and multiple meetings. So like a 3-week process can be condensed down into maybe a 10-minute simulation. I did this for a company that is in the energy industry, and they basically wanted to look at moving their rigs around and what contracts they could actually achieve with these rigs. And so it was a very interesting project. It only took a month or two to create, and it was a very simple use case for the software. Another example I will include is I was a part of a very large plant simulation model. In my case, I think it's the largest plant simulation model I've ever heard of, which is entailing creating shipyards and many aspects of a naval shipyard, and then going down to the level of detail where we're actually covering operators, we're covering an AGV moving throughout a plant. And then when you think of that on a large scale, we're covering, 1,000 or 3,000 different people moving throughout the process. We're covering hundreds of forklifts moving throughout their plant. And then at the end, connecting those naval shipyards to each other so that they can move together, work together, and kind of show you the logistics between the shipyards that we could model. Some other examples that I will talk about is just things outside of my project work, but things that are very useful. There's a lot of tools like OPC UA, which could be connected to via many different things. And then Socket is another thing that you can connect, CNC machines to directly. Yeah, and this is a big component of virtual commissioning, which is why I wanted to bring it up. Another thing that plant simulation can use is liquid simulation. Breweries have been using this. I know there's a lot of other, like Coca-Cola has been using this. And other things, cost analysis, and then VR integration and point cloud. So there's a lot of different portions to those areas, but those are kind of the newer portions of plant simulation, so that you can walk through a plant that maybe is not built yet, or you can do a point cloud map of a factory that's massive and put that into plant simulation so it reflects the actual dimensions and machines that are in that process. So those are just a few examples. I apologize if I was a little scatterbrained there, but the projects are usually long-term and take many years to conduct, especially the largest plant simulation model. And like I said, you can also go down to like a 3-week process. So I'm going to move on to the next portion, which is just a typical plant simulation project schedule breakdown. So defining a problem statement on a macro level. So maybe, do you want more throughput and less waste? Do you want faster output? Maybe more automation. These are some things that you would have to ask yourselves about your process and how plant simulation can help. And then you call us and we kind of break it down into a project. We break it down into the project scope and setup. So we make sure the right people are invited, that initial data gathering calls are in place, and that KPIs are defined and we know the right people to talk to after we define the KPIs and problem statement. Then we come on site, we talk to the real people working on these processes, we look at the machines, we kind of understand the process more completely so that we can define it in a virtual world and understand it. Once we're satisfied with that, with our understanding of your process, and we gather the data from, then we will begin to start creating the process. So we develop the model with a few checkpoints pre-established so that we can make sure that we're going along the right path with your team. We talk to engineers, operators, managers to just make sure they understand the nuance. We are testing during the entirety of the project, but specifically after we develop the solution on E right here, we are testing to make sure that we're matching completely the virtual world and the real world. So we're making sure we're matching KPIs, data gathered from a day-to-day basis, make sure we're hitting long-term goals in the simulation model, the long-term goals that you have completed in the past. And then we collect our findings. We kind of put together a nice presentation with a bunch of charts and graphs. We understand your process and how we could optimize it. And then we start doing some what if scenarios on the process. So we look at your current day, and then we decide, okay, according to their problem statement, they want to have more throughput and have less waste. So we're going to come up with a few what if scenarios that they can do. Maybe those ideas were found through our discussions with people on site, and we're just proving them out in the virtual world. But we go through those what if scenarios and then gather that data as well and put it in the final presentation for the customer. We train them after the final presentation, and that gets the stamp of approval on this product. We teach them how they can easily change these virtual models. And most of the time we're training them for a week or two just to make sure that they completely understand, and maybe even go through a few improvements with them so that they see how they can iterate on this model and come to maybe a version 2.0 in the future. And then after that is support. So that's kind of optional, but basically our team will support you guys for a bucket of hours. While you're using this model, maybe you run into an issue or two that we can help you along and fix. Or maybe you're just using it for a future what if scenario that you wanted to test in the model. It's a lot of different support that we can give you guys after a project is complete. But that is the typical Plant Sim project. I'm going to jump into Factory 51. I know if you've seen Plant Sim before, you've probably seen this model, but I'm just going to jump in and kind of explain the basics of this simulation, this discrete event simulation tool, and kind of walk you through maybe some common graphs, common charts that you can see in plant simulation. So give me 1 second. There it is. Okay. All right. So this is Factory 51. If you've never seen this before, this is a complete model of a plant. And I don't actually know what they are producing in this plant. I've never actually asked, but this plant is basically a bunch of different processes and machines. You're going to see some truck deliveries and for shipping and receiving. And then we also have this whole warehousing system here in the upper right that will also be utilized via automatic robots, I believe, and then a conveyor belt system to send it out. So there's a lot of things that are going to be moving in this. I'm going to zoom in on each part of this process and kind of explain what's going on. So I'm just going to start this, and we'll see some trucks arriving. You'll see that there is a forklift that is picking up the product and kind of a gantry that is moving things along to some robotic arms that are moving things to the proper places in the plant. So this is pretty impressive to set up and define how much product is coming through with a truck. You will also see that there are statistics that are being collected as we zoom in, such as trucks arriving, being incremented, trucks missed. Let's say if there's a backup. It's also keeping track of how many plates are currently in the process. So, so good things to see. And by the way, I don't know if you've seen this before, but you can actually click into any of these machines at any time and see statistics on them. You could change things in the middle of the process by pausing and then changing maybe a time or an angle on a robotic arm specifically. But for the most part, you don't really want to change things just to have a more accurate simulation run. Let's look at some of the statistics that are being collected. I apologize if you can't see this completely clear. It is a little tiny, but it does have a working percentage, a waiting percentage, where it's kind of waiting for product to be put on this line. There's a lot of other statistics that are pretty important in here as well. And you can do a lot with these statistics. Like I was saying, most of this solution can be done without programming, but if you want to get very specific, you can look into, maybe you want to do something every 50 parts into this robot. Maybe you want to do a maintenance cycle. So you can keep track of that and kind of add that into the model as you're fleshing it out and making it more accurate to what you do in real life. So let's move on to maybe over here, this side of the plant. You will see that there is a pallet system that is going on over here in the upper left. That is providing the pallets all the way over here to the shipping and receiving, and it might be going to the warehousing as well. But you'll also see something that we didn't see before, which is workers. So I'm going to zoom in here and kind of see how they're moving throughout this. They kind of look like ants in this simulation, but they do have intelligence, I swear. And these operators are moving according to priorities. Now, I don't think we'll be able to see their quote-unquote supervisor. It's usually called a broker. But we will be able to see their priorities based on just tracking one specific worker. So you can see these workers are going up to different stations throughout the day. You can also see, I didn't point this out yet, but at the bottom right, this is kind of the working time right now. So we've been going for about an hour in real time, or in this simulation. And so you're seeing the amount of movement that each worker is moving and working and kind of waiting for their next job. And so all of these machines are also able to be clicked into. You can see that this is an object because I clicked this and everything within it is selected. So another portion of this is that you can double click into any of these frames and then go into and select maybe a specific worker or maybe a specific product. And you can see why they're in that place, what they're doing, and exactly like what's going on. So that's kind of a very unique portion of plant simulation. And You can also see that there are parts being moved throughout these processes. These little pink things are the parts. It looks like there's two different kinds based on the colors, but that's another thing that you can define. You can define parts and what they look like. You can incorporate your own CAD models into this. And then, as you can see, we're actually packing them into these containers 3 at a time and putting them through another process that is maybe for all three of the products. So that is this portion of the plant. Let me just show you a chart real quick so that we can finish the summary here. All right, and so this is every resource in this plant. You can see they're all labeled as inspection 1, 2, or 3. Obviously, if you have better naming conventions, you can do that for your plant. But it basically shows the breakdown of how they have been working so far and what is currently going on with the process. So one thing to note is that there's a lot of failures in this portion of the plant. So it's kind of tough to think about how this is happening unless we actually jump into inspection and see, okay, maybe there's some rework happening, maybe there's some bad products in there. But we can really dive into each part of this process by examining these charts. You can also see the working percentage and then the waiting percentage, which should be higher working than waiting, but sometimes in a process where it is kind of a conveyor belt system, there is a lot more waiting than working going on when you're waiting for something ahead of the process to finish. All right. Okay, so back to the plant. This portion of the plant is actually pretty similar to this one up here. It is, I think, a little bit of a different layout, but pretty typical in terms of copying and pasting, which is a good thing that you can do in plant simulation. So if these two portions of the plant are pretty similar, you can just copy this frame and then paste it in the upper corner. And then just change what you need to reflect what is going on in that process. So the other thing here is these Sankey charts. So these are useful for figuring out where your workers are actually going. And I am going to show that if I can. And you will see it's a little more thick over here, as this is kind of the main portion of the process with operators. You see that they are going this room, so you can see that they're going in there quite a few times. Now that can be changed in a typical simulation model, but in this case, it's actually going back there because that's default and how it works. And then if we really want to, we could even get into drying and painting here and look into those processes, because those are kind of black box machines, and we can see exactly how many parts are going through there and how long they're taking. All right, I'm going to turn that off. And then we can also, another interesting thing is the part Sankey. So we can see their paths through the plant on these conveyor belts. You can even see the path from the trucks. And then another thing you can see is you can see the parts that are being stored for later in the warehouse. And so one thing that we can do, I can change the angle here. Sorry if that was a lot of movement on video. And we can just kind of see how this warehousing is actually working. It seems like it is using a conveyor belt system, and then it is packing kind of first to last. And as you can see, these are coming in and kind of finding the right product that are being transferred then to the truck for shipping out. So that is kind of all I wanted to cover on this on this demo, I know I was all over the place and kind of tried to explain a few useful tools that we could use. But one big thing that we can check out here is we can look at the HTML report, which is kind of a great summary of this simulation so far, and kind of look at some statistics that were gathered for the entire process so far. So you can see that we have a few different products. We have aubergine and strawberry. We can see how much throughput has been in throughout this entire simulation run of about 3 hours. And then we can look at the throughput per hour and how much it was being transported, how much it was actually being worked on, and kind of the value added, which you can kind of tweak in the background to kind of figure out which portion of the process you want to be value add and you don't want. It's not counting transportation in this. It's not counting storage. So this 4.2 is kind of counting basically production and only production. It also has this cost analysis in here. So we're seeing how much it's costing each of these machines, or it's even got these converters are the conveyor belts. And so it's counting how much it is to run these and how much per year it is to operate them. Oh, and it's even calculating some product costs as well. So if we scroll way down here, usually they have some charts down here, but I'll show you one of those just to summarize, and then we'll get out of this presentation and go, or get out of this demonstration and go back to the presentation. So if you, let's go here. So the last thing I wanted to call out here is you can see these live. I don't know if you've seen these move, but if I speed this up and kind of go to the max, you'll see these are updating in real time, of course, but you can look over these as a simulation is running for days, hours, weeks, and see how your resources are doing when they hit a significant snag. It's very useful for scheduling. And you can really look at how you're producing and how fast you're producing these products just with this chart. So I'm going to go back to our presentation here. Pause this. Okay, so the last thing here is just the poll. Chris, if you want to jump in here for that.
Yep, I can do that. Beautiful. Appreciate it, Patrick. Yep, let me engage our last poll question before we get into live Q&A. As you witnessed Patrick's presentation on the capabilities of plant simulations, let me go ahead and launch it. So the question is, after what you just witnessed from what Patrick just showed, which capability interests you the most in regards to your facility? Is it the throughput and bottleneck analysis? Is it real-time production monitoring? Is it being able to automate some of the experimentation that you would either like to do or have tried to do? Or is it being able to validate improvements before you actually implement it with this type of solution? So we'll give folks a few seconds to go ahead and input their answers to this poll question, and then we will we'll finish with your recap, Patrick, and then we'll do a live Q&A with as much time allotted as we have as well. And then also as a reminder, folks, when you do exit today's session, we do have a quick and efficient survey that we'd love for you to take. Again, your feedback has been instrumental in us making sure that we're giving you the right information at the right time. All right, let me give folks just a few more seconds, Patrick, then we'll go ahead and display the results, and feel free to chime in with what you see, and then we'll jump right into the live Q&A session. All right, we've got, okay, at least a little over half, 50% of our audience has went ahead and inputted their answer, which is good. So having said that, let me go ahead and end and share the results, Patrick. Here we go. And that's what you see on the screen. So the number one interest is being able to validate. Patrick, I didn't know if you had any thoughts or comments on that.
Yeah, I mean, that is very plant simulation as well, especially validating when a new machine is coming into the process. Maybe you want to test in a completely new part of the process, such as adding robots to a factory floor. And so it's a very key use case for plant simulation.
Love it. All right, let's go ahead with your last slide, and then we'll get into Q&A.
Okay. Okay, so what is, wait, let me present this real quick. Of course it's doing this. I'm sorry, I'm not gonna present it fully because I'm having difficulty with 3 monitors.
That's fine. Just if you want to slide that over. Yep. There you go.
Yep.
Yep.
Okay.
All right, you're
good. So I would ask a few different questions when you're trying to figure out if plant simulation is the tool for your specific needs. Would a digital twin help your engineers conduct studies more efficiently? It's a very useful tool. You can shove any portion of your process into this tool and kind of have your engineers playing around with it as they see fit. And then what optimization efforts could be jump-started through a simulation model? This is a key part of the digital twin concept, and optimization does start when you do have that duplicate of your real-world process. And then with new machines and processes being invented daily, what could your production system look like in the future? Like the poll showed, it is a very interesting question to answer. One thing I will say, we've used these tools not only for current day simulations, but for way in the future simulations. That specific energy case study project that I did was for the next 5 years, I believe, kind of comparing rigs and contracts and kind of seeing how they could optimize their scheduling and make the most profit. And so that is kind of a question that everyone is thinking about, and I think plant simulation is a key portion of that answer. So schedule a 30-minute assessment with us today. It won't take long to talk through a problem statement or any KPIs that you are interested in improving. And then we can do a few different things like a current state analysis or a gap assessment to kind of figure out how we can help. So that is pretty much it. That's all I had.
So it'll be, yes, 52 plus 180.
Awesome. Well, let's jump right into Q&A. Sorry. I need to avoid the acronyms, right? There's so many acronyms. Doesn't matter what industry you're in, right? Sorry. Questions. Let's do live questions. So the first one, let me find my questions section, this is from Daryl, Patrick. Can you talk a little bit about the capabilities of being able to import from other systems like a SAP or like an inventory management tool? There's 2 parts to that. So let's start with there, and then I'll add the second phase of his questions if you want to jump on that one first.
Sure. Yeah, so there's a few different capabilities here. A lot of the tools in plant simulation are already built in. So there's database tools that can connect. There are tools that connect specifically to outside systems. One of them is OPC UA, another is Socket. Those are kind of useful in terms of connecting to, open ports in your systems so that you can kind of pull the data directly from an MES system or anything like that and pull it into plant simulation, maybe in a spreadsheet, maybe to a folder so that plant simulation consumes it on a minute basis or a second basis. But there's a lot of different things you can do to set up one of those systems and make it work with plant simulation.
Love it. Love it. Okay. The second piece of that question from Daryl is this: since it does kind of the what if simulation scenarios, what about incorporating optimization models as far as like, sorry, let me rephrase that question. Can it incorporate optimization models with recommendations against maybe situational constraints? Can you talk further about that?
Yeah, you can. One of the coolest things I think about plant simulation is there's a lot of functionality you can define in terms of changes. So maybe connecting a menu to a certain portion of your process. So if you're doing optimization, let's say, one of the best tools for that is genetic algorithms, and another tool is called Experiment Manager. But if you have a menu that specifically runs those tools for you and recommends some results afterwards, it's probably the best use of plant simulation that you can do. I've done in the past for, I'm thinking of one specific customer. I made a huge menu, multiple tabs that they could customize any portion of their simulation model, and even duplicate that file and make another version of it, and it will have that same exact interface in it and work consistently with the new file, maybe the new naming convention, maybe you add another frame to it, to the simulation model. Anyway, I'm talking too specifics, but I will just say it is possible. There's a lot of different things you can use for it, a lot of specific tools you can use with it. And two of those, genetic algorithms and Experiment Manager, are built into plant simulations. So easy to use.
Beautiful. All right, we do have only a couple minutes left. I'll get through as many of these as we can, Patrick. The next question I have is, what types of production systems can this plant simulation platform handle?
Go off mute. It can model anything. Like I showed you, we zoomed in on the Factory 51 model. It can model a specific CNC plant. It can model specific human operations. It can't model it to the level of details like Process Simulate can, where you're actually looking at safety and everything like that. But it can model the time, the delays, anything that you need in terms of a specific operation. The height of it can go to, maybe you have a whole warehousing system. I would love to see it in, let's say, an Amazon plant where they have AGVs everywhere, moving about. Each one of them has intelligence to them. And that is something very complex, but it is something I've seen in smaller terms in plant simulation over the course of my time working with it. But yeah, if it involves anything like discrete events, parts moving, machines processing, decisions being made, plant simulation can do it. So
beautiful. Good stuff. Well, unfortunately, we've run out of time, so the other questions we'll make sure to take offline, Patrick, and get back to the audience that asked them. We appreciate everyone's time today. Patrick, thank you for a very insightful presentation around plant simulation. It boggles my mind the amount of capabilities that it has, and I just don't think enough people know about how they can help optimize their processes and their factory floor and whatnot.
Yeah, it's a very flexible tool, and I don't even think people who have used it for years know of the capabilities of this tool. It's very complex, and even though it's complex, it's very simple to use. So.
Yep. And that's why we're here. That's why you're here, right? So again, folks, as a reminder, when you exit today's session, please take our quick and efficient survey. We will send a link to the recording within a day. By the end of tomorrow, we'll send you a follow-up email. We appreciate everyone's time today. We look forward to talking with each and every one of you down the road. And at this point, this session is now ended. Thank you very much, Patrick, as always. And we'll talk to each and every one of you very soon. And enjoy the rest of your day. This session is now ended. Thank you.
Thanks, everyone.